So in the test and simulation industry, hydraulic systems play a crucial role in providing precise control, high forces, and rapid response times. You'll find these in testing environments for automotive, aerospace, and industrial applications, where it's critical that realistic environments are replicated to ensure that products and technologies developed will be able to perform well once they're out in the real world. I'm here today to share with you exactly how Domin Valves can enable these hydraulic systems to manage fluid power effectively and allow products to meet the stringent performance standards that are required. So let's explore some of the challenges that manufacturers are currently facing today within the industry and how Domin Valves can be implemented to solve some of these. So as you might know, testing applications demand extreme precision, whether that's within fatigue testing or motion simulation. Just small deviations can lead to inaccurate results. Servo valves need to deliver smooth, predictable control, but issues with instability and hysteresis can make this difficult. That's why high-performance valves with closed-loop control are critical. So next up, really a huge problem within the industry is durability and reliability. Servo valves experience constant exposure to potential oil contamination, especially within the pilot stage of a traditional two-stage servo valve. Even just the smallest contaminants within the hydraulic fluid can block critical control orifices, leading to performance degradation or even failure. Advanced filtration and a contaminant-resistant design is the true key to extending the valve life in service. Another challenge, particularly in demanding environments, is valve dynamics, things like step responses and frequency responses. A slow response time essentially for the end user means limited cycle time and capped performance. By switching to a high bandwidth servo valve, we can essentially eliminate this issue by providing the speed and accuracy required for the modern day test system. So reliability within test and simulation applications is critical. Some of these machines will be running 24/7 every week, enduring millions and millions of cycles. So a valve breaking and not completing that cycle means wasted data and wasted time for the customers. So reliability is of paramount importance. Reliability has been a little bit of an issue over the past few years and few decades actually for manufacturers, because they're completely reliant currently on traditional two-stage mechanical feedback valves. And due to the nature and the complexity of these designs, there's quite a few weaknesses that leaves them prone to things like contamination within hydraulic oil. Let's talk about the pilot stage, for example. These are completely dependent on the modulating of very small control orifices. So you can imagine if there's a particle within the oil that gets within the pilot stage and clogs these small control orifices, these can render the valves completely unusable, meaning they have to be removed, sent away for repair and maintenance, and causes huge downtime. So there's a big push to try and bring in valves that have improved contamination resistance and guarantee extended life of the product. And with our Domin valves, we've been able to address this issue directly. By having a single stage design without the pilot stage, we've completely removed the weakness to contamination. Additionally, we've designed our valves from first principles, learning from the issues currently present in existing designs and working to ensure that we remove failure-prone components within our valves. And overall, what this has led to is our customers using Domin valves are having valves lasting much longer in service and often spending significantly less on routine maintenance and valve repairs. So in addition to performance improvements and reliability improvements, energy savings is actually a huge benefit of switching to Domin valves that most manufacturers don't think about. So due to the nature of a typical two-stage servo valve, there's a requirement for constant high-pressure fluids being delivered to the pilot stage to even move the spool at all. Whereas with a direct drive valve, the movement of the spool is completely driven by electronics means through a brushless motor. This means that the spool can be moved even in the absence of any hydraulic fluid, let alone high-pressure hydraulic fluid. So in the case of a typical two-stage servo valve, the customer's pump is requiring the constant generation of high pressure to deliver to the valve, even when there's a requirement for the valve to not move. And what this means is this energy is really being wasted because it's not being used for actual work to move an actuator and to perform a test on a sample or to simulate motion control in an automotive test simulator, for example. And we've done the calculations, and based on typical uses of a valve, This equates to around €400, £400 of energy wasted per year per valve, just on having this requirement for constant high pressure fluid for the pilot stage. Many of our customers have many more than one valve in their facility, often 30, 50, sometimes even 100. So you can imagine how quickly this energy saving ramps up. So even the cost of switching to a valve might seem like a big expense at the front end. Actually, there's a huge return on investment available here, where the valves really pay for themselves and actually start rewarding the customers with savings within a few years. So we work with automotive companies throughout different manufacturing stages of the car and with different elements. And a key one that we've worked a lot in is in tyre testing, to create equipment that simulates the wear a tyre will go through in the real world. So things like resistance to potholes, resistance to different temperatures, resistance to different wear conditions. And Domin Valves are really the heart of these test systems. By providing our customers within the tyre industry with high-speed, high-precision servo valves, we can help them to simulate real-world scenarios within their laboratories. And also through the high step responses of our valves and high-frequency bandwidths, we can perform these tests very, very quickly and maximize the number of tests they're able to perform per day. And as a result, what this means for our customers is the increased throughput of tyres through their testing, which means that they can develop tyres quicker and more efficiently, meaning they can bring new products out to the road faster. A big reason why manufacturers don't like switching to a new valve is mainly due to the mounting interface, for example. There's many different ISO standards available today. Even though the valves might be delivering the same hydraulic fluid, they might not necessarily be compatible with the existing machine. And we took this feedback on board from our customers very seriously and have spent a lot of time diligently designing slim, state-of-the-art adapter plates made in-house. And what these adapter plates mean is that they can be installed directly onto the customer's manifold with the Domin valve mounted on top, enabling them essentially to integrate Domin valves into their machines without unnecessary expenditure. It's our mission here to make it as easy as possible for our customers to choose Domin and experience the benefits.